That was probably Jeff who started that. And don't forget that every alternate week from these delegate assemblies, we have Stat Club on Fridays. Everyone is welcome to come along. This is an open co-working session where you can come along and ask any questions you want, or try to write notebooks or share your work. And it's a great place to just ask questions and become more familiar with the science platform and the science pipelines. Just to remind people again about the DP0 New Friends Program, Melissa has already mentioned this. There's a link to a community post about it. This program is attempting to pair science collaborations with long-term members in science collaborations, with new Rubin DP0 delegates to try to help them on board and become familiar with Rubin, the data products and services. The contact for this is Jim Annis. So please reach out to Jim or to us if you'd like to get involved in this. Just the delegate profiles, we have about 7 in that we'll go through after Keith's presentation, but if you would like to add your profile and just give us a quick 30 second to 1 minute talk about yourself, who you are, what you do, what your interests are, this would be great. We're really excited about getting to know more people, more of the delegates. This is a template here. Feel free to copy that to create your profile. Okay, so we won't go into the delegate profiles now. I will hand over to Keith, who is going to take us on a walk through some advanced data visualization techniques. I'll stop share.
Thanks, Leanne. Let me do a share screen here. Okay, are you seeing the share screen now for the Jupyter?
Yes.
Jupyter Lab, I guess. Okay, great. So hi everyone. I'm Keith Bechtol. I'm part of the commissioning team for Rubin Observatory. So what I'd like to do today is go through 3 notebooks having to do with data visualization. And the emphasis for today is going to be on visualizing large data sets and creating visualizations that offer some degree of interactivity so that it's not just a static plot, but you have the capability to do some real-time adjustments to the visualization and to effectively do some analysis actually in the visualization itself. So this is going a little bit beyond some of the typical scope that we think of in matplotlib tools. I am most familiar with matplotlib. That's the sort of the main plotting library that I've been using for my own research for the past several years. What we'll do today is talk about basically three new Python libraries. Well, not new, but new in the sense that they offer some more advanced visualization capabilities. So we'll talk about those. So the first of the notebooks is on images. The second of the notebooks is on catalog, tabular data. And then the third is combining aspects of image and catalog visualization to basically tie these two together and show how you can connect interactivity between the two of them. So let's go ahead and start with the images. So this notebook is called, I think it's called Interactive Image Visualization. I think that's it with the image here. And there's another one called Catalog. And these are in the main tutorial repository if you want to follow along. I'm using a large container because some of these visualizations we're going to use, particularly in the second notebook, involve lots of data, something like 200 million rows. So I'm using a large container, and we've noticed some intermittent performance this morning. So hopefully everything will go well, and the kernel won't reset as I'm going through this. Leanne is standing by in case we have a reset.
We have some people who are not able to access the notebook yet. Leanne, did we want to give instructions on how to do that, or are we just going to proceed?
Can you start a breakout room when the presentation is finished, and I will go there and help those people.
Sorry, thanks, Tina, for that question. Yeah, we can. It's in the tutorial notebooks, as for all the tutorials, but we can deal with this after the session if people are still having problems.
Yeah, it's probably worth mentioning that these notebooks were updated within the last 24 hours. So you may need to do a Git pull to get the latest versions of these notebooks. They're labeled 8A and 8B. Okay, so the stepping through these notebooks, there's links here to the 3 libraries that we're going to be emphasizing today. So these are Holoviews, Bokeh, and Data Shader. So Holoviews is it's basically an alternative kind of plotting from Matplotlib that has a somewhat different philosophy. At least the way I think about it is that it's more like you have data structures and then you're effectively annotating them to create plots. So as opposed to Matplotlib, where you sort of make, you sort of have a plotting library API, and you're basically giving data to the to the functions that are defined in the plotting library. In this case, it's more like you have a data structure, and then you're basically telling it how to render itself. So Holoviews is it's flexible enough that it can work with different backends, but the backend that we'll use today is Bokeh, because this offers lots of interactivity, including brushing and linking. And we'll also use Data Shader today, which is a library that's suitable for visualizing very large data sets. So all 3 of these are part of this Holoviz ecosystem. So again, I'm running on the IDF here. To go through the setups. So some of this is just standard Python imports, AstroPy that we'll use for scaling the color scale of the images. We import the data butler so we can retrieve data later. And then we import the Bokeh and Holoviews libraries and some of the particular classes that we're going to use. Important here, you want to set the extension for Holoviews to use Bokeh, so that you basically use that backend and you can use all the interactive features. And then we're going to use this output notebook so that the Bokeh plots are displayed in line in the notebook. Okay, so we can check the versions of these packages. The API does change on these from time to time, so it's good to check the version, suppress some warnings, and then I'll mention that I'm using the weekly 2021-33 for this demo. Okay, so let's go ahead and grab some data. What we're going to do here is grab the images and the associated catalogs for a single detector and for a single patch. So the way that we're specifying this is that we specify the repo, and then what we're going to do is that we're going to, this next cell 6 is for retrieving the individual detector image. So this is a CalExp, is the data set type. And to uniquely specify this, we need to give it a visit and a detector, and this is because it's a single exposure. It has a band that's associated with it as well. The other thing we're going to do here is grab the source table. So these are you can think about these as the single epoch source detections for this detector. So at this point, we have the image itself and the in the source table of the detected catalog objects. This next cell 7 is doing the same thing, but now for a COAD image. So it's grabbing a single patch, which is this is the unit of data processing for the COAD. So you need to uniquely specify it. You need to provide a tracked, patch, band. This line grabs the deep COAD dataset type, the COAD image, and then we want to get the source catalog. So this is the COAD objects that were detected in this patch. I'm going to go ahead and run these cells actually just to make sure that everything is up to date with the visualization as I'm going through this. Okay. So this next section is basically stepping through some of the visualizations capabilities with Holoviews. As I mentioned before, Holoviews has a somewhat different philosophy and organization than Matplotlib. The core primitives of Holoviews are these elements. So you can think about this as the display, and it has data that's associated with it. I think part of the reason that that Bokeh and Holoviews may have been designed this way is to make it easy to do the brushing and linking between interactive plots. And we'll see how that works later on. I'll just also mention that right for this notebook, we're going to be doing the image displays with Bokeh, so, basically showing the pixel level images. But there's other tools for doing this, and I believe the delegates have seen how to use AFW display for this in one of the previous sessions of this delegates. Okay, so what we want to do next is set up a color bar scaling effectively, so a Z scaling for the images. So these are calls to AstroPy library functions for doing this. And then we're basically getting set up to display an image here. One of the steps that we need to do is in order to, we basically need to get the bounding box for the image that specifies basically the pixel dimensions of the image, so that we basically render the portion of the image that we want to show. So that's what this line with the bounds image is going to do. What we can do next is then configure some of the options for the plotting. What we're going to do in just a moment, I can see where this gets specified. These image ops are going to be passed in as keywords here. So we're basically defining the dictionary of these options. And this is an example of what we mean by saying that it's sort of like you have a data structure and then you're sort of annotating it to provide the details of how you want to display it. So effectively, these are these details about how you want to display the image. So you can specify the size, padding. You can specify where the toolbar is located in the tools. We'll see how this works in just a moment. So let's actually go ahead and render. Oops, did it not?
You forgot to run, I think, a higher up cell.
Oh, thank you. Good, I missed one.
That's all.
Great. So let's go ahead and render this so that we can see what's happening. So here's our rendered image, and you'll notice earlier that we set the tools. We set this hover tool, which is one of the tools that you have in Bokeh. And what you notice is that now if you move your mouse over the image, you can actually find basically the pixel value at that location. This has a Z scaling, so you can see that the range is not, for example, like ADU counts or photoelectrons, but is scaled. What else do we want to say here? So yeah, so you can interactively you can mouse over and see the pixel values. And one thing that I'll mention is that we're using this rasterize here, which is one of the classes in Holoviews that basically it chooses the appropriate resolution of the image so that as you zoom in and out, it adjusts. So if we zoom in on a particular vignette in this image, you'll see that it starts off at coarse resolution, right? Because it was using the pixelization from the full view of this detector. And if we zoom in more, right, you can see that you eventually get down to seeing the pixels. So it has a sort of dynamic pixelization, which is a really nice feature. We can zoom out. If you don't want to have these hover tools, you can turn that off.
Keith?
Yes?
Let's make a very small suggestion. We discussed this morning. If you go back up to image ops, just change the size of the image to 600 by 700 from 400 by 500. So when we get to the source overlay. It looks much better. Great, thanks.
There we go. Good. Yeah, so this is even a nice review. Okay, so what we're going to do next is we're going to overlay the source detections on this image. So this is an example of this interplay between the catalog and the image visualization. So first thing we can do is specify the coordinates. So we're getting this from our tabular data of the catalog. In this case, we can see there's about 2,500 individual sources detected. And now we're creating a Holoviews object that's actually going to render these points. So what we're doing is that we're feeding in the coordinates. In this case, it's the X and Y instrument detector pixel locations. And we can specify the options for how this is going to be rendered. And we can also make a custom hover tool here. So if we actually go ahead and render this, so now what you can see is that the orange points are the orange circles are representing each of the individual detections. Again, we can zoom in and see this correspondence between where you see the light in the image and the detections. So that's good. And you can see that the hover tool now is not related to the image, but is now giving us information about the source detections. It's specifying, it's telling us the X and Y coordinates, and we define that hover capability up above. Okay, so let's go ahead and press onwards. So what we're going to do next is show some of the interactive capability in terms of being able to explore selections in the image. So what we're doing here is that we're going to draw a box on this image. So let me go ahead and draw a box so you can see it. So what we've done here is that it's the same image, but we've added this capability to create this box, and we can find out the dimensions of this box. We can basically find the pixel coordinates. So this is sort of a bridge to being able to do selections where you can imagine selecting regions of this image. So the way that this is set up is by creating what's called a dynamic map. And the dynamic map, it takes in, basically it passes in a streams object that's defined here. Okay, so in this case, the streams is a bounding box, basically specifying a region in X and Y. It's associated with the source, which in this case is the image, so that as you use the selection tool on the image, it basically has the stream, which then passes the information through the dynamic map, and will do the updating on the image. And at the same time, it updates the coordinates of the box so that we can actually access this selection later on in the notebook. So if we were to select now a different region, and now we take a look at this box, you can see that the values have changed. So again, this is an example of how you can begin to introduce more interactivity into the displays. Another example of how you can do this is by being able to click at various positions in the image. So in this case, you can see this white X that's marked, and we can click at different points in the image, different positions of interest that we might have. And what we've done here is we've defined a different kind of dynamic map that's using the streams tap. So in this case, every time you click somewhere on the image, it's updating that stream such that it updates the rendering of where this X is drawn on the map. And we also know it also updates the information about the coordinates of that marker, so that what you can do now is get information where this marker, which we call this pos XY, position XY, you can use that to get information about the image itself. So what we're doing here is using those X and Y positions to basically grab the associated pixel value from our image. And so in this way, you could click anywhere on the image and know what the value is. And you can imagine using this type of tooling to build more sophisticated interaction. So that's the end of this first notebook. Maybe I should pause here to see if there's any questions.
Hi,
Okay.
Keith. Just a quick question.
Yes.
Sherry here. Is there a way to move that box that you were dragging around interactively?
I'm not aware of a way to sort of drag it, if that
Okay.
makes sense. Like you can basically draw it anywhere you want
Right.
by using this selector tool, this box select tool. But I am not aware of a way to sort of drag it around. Maybe somebody else knows.
Sorry, Keith, was, try to leave the box there and go up and click on the second tool in the hover, the cross. Yeah, and then see if you can move the image around. No, okay, so the box moves.
So this is like a panning tool. So there's nice pan and zoom features, right? So you can zoom in and you can pan around.
But yeah, the box stays with the image.
But the box stays in a fixed location relative to the pixels, which I think is kind of the behavior that you would want, actually. Yeah, I think so. That you basically, we've basically tied at this line, we've tied this box selection to the image pixels effectively. Okay, then let's go ahead and.
Someone had asked another question in chat.
Oh, good. Okay, great. Thanks.
Do you have both the box and the cross features on the same image?
You could. So probably something that I should mention. So the way that we've done these overlays, the syntax for doing this in Bokeh and Holoviews. So when you use this this multiplication syntax here, what it's telling you is to actually overlay these two different representations in the same panel. So what it's doing, like what's actually happening here is that you are first rendering the image. So basically the pixel level image, and then you're overlaying the source catalog positions on top of it. And then this rasterize here is taking that whole display and making it so that it's dynamically updating the pixelization as you're zooming in and out. So the multiplication here again is like it's an operator for indicating that you should overlay. And what we're going to see in the next notebook is an example of where you use a plus operator, and that creates two panels next to each other. Not sure if that answered the question.
Yes, it did.
Any other questions at this point?
How can I make this work with a GRB image?
That's a good question. I haven't seen an example of that. To make a multi-band, basically a color image that represents multi-band data. I have not seen an example of that yet. I'm not sure if anyone else has created.
I haven't done it, but that's a really nice suggestion, something that we could look into trying to do.
I was going to say it sounds like a great project.
Nice.
for the hack time. Any other questions at this point? Okay, then let's go ahead and move on to the catalog level visualization. So again here, the emphasis is on being able to visualize very large data sets is what we're going to be focusing on, assuming that a lot of the standard visualization can be done with Matplotlib, for example. So I'll just step through what's happening in this notebook. The initial setup is the same. And I've already run the first cells of this notebook in advance because there's a query that takes several minutes to run. So just in the interest of time, I've run some of these cells in advance. So what's happening here is this should be reminiscent of an earlier notebook in the series, showing how to do the TAP queries. So what's happening here is that it's doing a catalog query over a region where you can specify the radius, and so you're grabbing a set of columns from this object table, doing a join against another table, and again it's a circular selection where you can specify the center and a radius. So what I did earlier this morning is that I called this command. Basically specified the sky coordinates for where to do the search. I picked a radius of 4 degrees and then did the query. So this query here is a string that has the contents of the query. You submit that job and you run it. And then this particular query took about 9 minutes to run. And so this was a query that was run asynchronously. So it ran for 9 minutes, and then later on in this cell 15, you can fetch the result. So downloading, basically loading that into memory in this notebook, that query result took another 8-9 minutes. And then this particular data set has 20 million rows in it. So it's quite a large data set. So that's the basic setup. We're going to try to now do some visualizations with this large tabular data set. So, go ahead. Is there a question?
Just one. No, it's just a minor comment. The 8.5, 9 minutes that you mentioned is actually the time taken to fetch the results, not to actually run the job.
That's right. That's right. Yeah. So that's the difference between the cell 14 and cell 15.
And one other thing I'd just like to ask all the delegates, please don't run this. If you're playing along at home, please don't run it now, because if everyone launches an asynchronous query to the servers of this size, it will not be good. But do try it after this tutorial at some point later.
Yeah, thanks a lot for that reminder. I would recommend that if you're doing this for the first time, you may want to pick a smaller radius, like pick a radius of a degree or something like this, or smaller. You'll still get an intuition for how all these tools work, and then maybe at a later time use the full region just to increase statistics. Good. So we've got this data in hand. One of the things we can do is now this is in memory is a pandas data frame. So we can use pandas data frame syntax to define new columns easily. So what we can do is we can define columns for some colors if we want to make color diagrams of the objects from this object catalog. We can also create custom columns that will represent information about the type of object. So in this case, we're creating a custom column that has a string label, truth type, so that because we have the truth catalog as part of our query, we know whether as an input the object was a star, a galaxy, or a supernova. So we basically can create a column that has these string labels to easily select the particular type of object that we're interested in. So what we're going to do first for some of these visualizations is we're going to pick a subset of 20,000 points just to show some of the basic functionality of the Holoviews. tools for rendering tabular data. And then we're going to later on use the full data set. So let me go ahead and run all these cells. What have I done wrong here? I guess this is an assertion statement. I wonder why that's different. I hope everything is working.
I'll check offline, Keith. I think.
Yeah, let's press onwards. I think it's probably working. But let's press onwards. Okay, so the first thing we're going to do is just make a simple scatter plot with Holoviews. So if we go down to the cell, this is an example of where we're using the scatter element. We're passing in this data that had the 20,000 rows in it. And this is just basically sort of the first type of scatter plot that you would make with the Holoview syntax. Again, you can set these options to adjust how the rendering is done. What we can now do is show a different type of visualization, basically a histogram. So this is one of the other key types of visualizations that you want to be able to make. So here's an example of creating a histogram. The syntax here is calling Holoviews a histogram, passing in the bins and the counts that were generated above with the numpy histogram function. And you can specify options to give titles, axis labels, colors, the size, and so on.
Keith?
Yes?
Sorry, I'm just going back to your, I think that you've got actually an empty data set. That's why the assertions failed. They did their job. That's what I think's happened. So given that you've already run this notebook and you've produced the plots you're going to talk about, I'd say don't try to replot.
Yeah, let's try.
I'm fairly sure your data set's empty.
Well, we can do a test real quick.
No, okay, maybe not.
Yeah, it looks like it has, yeah. I have to say that sometimes I find it easy to get tripped up when I'm working in a notebook in these cases, because you can run the cells out of order. So sometimes there's funny behavior when you run out of order.
Run the one that sets star galaxy supernova truth type. It may be that star galaxy supernova aren't there. Okay, I don't know. I'm not sure.
Yeah. Okay. Good. Well, let's go on until we encounter an issue. So here's the histogram that we were just talking about. Again, you have the typical interactivity of being able to zoom in and pan and so forth. So now we're going to see an example of how to create a layout. So this gets back to the question that we had earlier about whether you want to display, when you have cases of multiple types of data that you want to display, do you want to show them as an overlay, or do you want to show them as sort of side-by-side panels? So this is an example of where we're going to have multiple panels, and we're actually going to link them in this case, so that if we go ahead and run this. Okay, so the way that we did this is that we're now creating this layout by using the plus operator instead of the multiplication operator. So you can see that for this 3-panel figure, when we render this, this is specifying the left panel, the center panel, and then the rightmost panel. So in this case, we're showing the scatter plots that we made earlier, and then also this histogram. Now, one of the features here is that the 2 leftmost plots are linked to each other, so that if you zoom in on one, you also zoom in on the other, right? So this is an example of where the axes are tied to each other, but this histogram axis is not. So this is an example of how you can start creating visualizations that have some linking between them. In this case, it's basically like a composite of the previous visualizations that we made. If we go onwards, we can do some more types of scatter plots. And in this case, I'm trying to remember exactly what this one was intended to show. I believe this was showing some of the ability to just adjust, customize the rendering style.
Yeah, that's correct, Keith. It's showing you how you can create a dictionary for all the different plot attributes, and you can reuse that as part of any plot. So invert axis, for example, is something quite specific to this plot, but the plot style dictionary that has been pointed to here is a lot of very generic layouts that you might want to reuse with many plots.
Good.
It's also demonstrating that, so here we're using bokeh. I've also shown how to give a matplotlib specific customization. And one of the exercises to the user at the end of this notebook is to try to do this with a matplotlib backend and see how you can use Holoviews with very different, many different plotting backends. And so that's an example there. And if you run this with matplotlib, you'll see a different looking plot, matplotlib style.
Good. Yeah, thanks for clarifying that. Okay. So another one of the tools that you can use in Holoviews is defining. You can basically define the dimensions and give more detail about how these are displayed. So you do this with this Holoviews dimension class, where you can basically tell it which column to use. You can specify a label, and you can specify a range. And so what you can then do is that when you are invoking one of the displays, in this case, one of the elements, like a scatter plot, what you can do is that you can actually pass in these dimensions effectively. And so it knows about the data, which is the stars, right? So in this case, it's a subset of this 20,000 row table where we've done a selection to get the stellar objects. So this looks like the way that you do selections, for example, in NumPy. But now we're passing in these dimensions, which effectively tell it how to do the axes. So if we run these cells, this is just showing another way of, now something has crashed. What this was meant to show was the scatter plot with the histograms on either side. I'm not quite sure why this isn't working now, because this worked fine above. I feel like maybe one of these columns has been run out of order. The issue, normally what I would want to do here is to restart the kernel and make sure that it's a clean slate. But unfortunately, because this data set takes about 15 minutes to do the query and fetch, I don't want to do that interruption right now. So I'm trying to think about the best way to proceed. I wonder if
best way would be you save the 2000 key data set as comma separated file and upload it again.
Yeah. Let's see if we can go onwards and try our luck, because I think what's going to be really interesting is if we can get to the part with visualizing really large data sets with data shader. Again, what this was meant to show was the scatter plot, but then you would have the histograms with the projection in the horizontal and vertical axis on the sides. And that's actually quite easy to invoke by, it's basically annotating our scatter plots with this additional hist syntax to create those projection histograms on the 2 dimensions.
So Keith, if you try it without the stars selection there, does it work then? Because I'm wondering if that was like the cell that those asserts failed up above was doing the truth type selection. And so if you instead, yeah.
I think that's what's happened, Jeff.
Yeah. Okay. So it must have been that that my stars selection got updated in a later cell in the notebook, and now we're running it out of order.
I mean, the color plot's not as pretty, but
How did you fix that again?
So this was only because I had previously run cells at the end of the notebook and it updated the stars. So instead of putting stars here, which is probably modified by a later cell in the notebook, I just plugged in the data 20K here. So this is that tabular data frame that has the 20,000 rows.
This illustrates one of the problems with notebooks you have to be very careful about, is that if you run cells out of order, you can get quite different results. So you have to be quite careful about that.
it also illustrates why those assert statements are in there.
Yeah, exactly.
To like that clued us in before that one of those truth type selections had gone wonky.
Yep.
I bet we'll see where the problem is as we go through this. So now we have this nice visual. You can see how it has the projection, and again, you have this nice linking where when you zoom in, you'll notice that the projection histograms also are adjusting to meet that axis range that's being displayed. Good. Just to mention here, there's other ways of specifying these options. This is sort of a not recommended way of doing it, using sort of an older style IPython magic that's specific to notebooks. So again, this isn't really recommended, but it's another way of being able to specify the options on these plots. So let's keep going here. So here's an example now where we're updating we're updating the hover tool. So let's go ahead and zoom in so this becomes a little bit more apparent what the advantage is. If we hover over a particular object, so here we go, I'll get my mouse in the right spot. Here we go. So it gives you custom information now with the hover tool. And the way that this was specified was by creating this, updating the tooltips on the hover tool, so that instead of displaying just what were the coordinates that were given to the scatter, which would be the default, what you can do now is you can actually basically change which columns are displayed and also the way that they're displayed. For example, whether it's whether it's displaying as a numerical value or not. Yes.
If you hover over one of the points, you can see that the type is nan. This tells us basically that the whole setting of the truth type, that cell failed. And so any of the previous selections based on stars or galaxies or type has failed. I think it's clear now that that's what the problem was.
Yep. So that's where we're seeing the
that
issue.
should normally come up and say star or galaxy and tell us what truth type it is.
Yeah, if I can hover over one of these. Yeah, so this is where you can see that. Okay, so what we'll do now is create some linked plots and data brushing. And let me actually go ahead. I think some of these are easier. They're easier to understand. Oh boy. Now we're starting to run into issues. I was going to say that these are easier. Let's see, maybe there's an easy way to fix this in real time.
Keith,
Yes.
an easy way maybe to fix it in real time is to go back to the original query, change the search radius to be 1/2 degree. That will return very quickly. All these plots will run, but we won't have the very nice data shaded, showing how to data shade and render 200 million points in a couple of seconds. But we could address that in the breakout.
Yeah, maybe that's the easiest. Maybe that's the easiest thing to do.
I think what you were seeing there too is that was exactly the cell where that stars selection
Oh boy,
was.
now we have the server error.
Oh.
We're having bad luck with our technical issues today.
Yeah.
I'm going to see, let me just see if any of these other cells will actually render so that we can talk about them, because this is where
Keith,
I think some of this data shader stuff is actually some of the nicest. Okay.
If you don't have it, Keith, I have some rendered cells. If you don't, I could share.
Let's see if this works. Okay, so it seems like some of these cells are still going to be fine. So let's focus on those. So one of the powerful things that you can do with Holoviews is this concept of the link streams and creating brushing and linking between the panels of a display. So an example of that is shown here, where what you can do is that you can specify the points here with the data that is input, and then you can just declare the streams. That's a selection that uses these points as the input, and then you can define a function that will basically use that selection and then update the display in a second plot. And then the way that this actually gets activated is by creating this dynamic map. So what this allows you to do then is on the left plot, you can make selections, and then they're updated in the right plot. And another really nice aspect of this is that you can actually get the indices of the selected objects. So if we were to say selection.index here, you actually get all of these indices, which is really nice. You can imagine doing all kinds of sophisticated analysis where you make a plot, you pick out some objects of interest, and then in the notebook, you now have access to those objects. You can select that subset. Okay, so let's go on to data shader. And I hope that this works, because we're now not doing the previous selections, but we're going to use this full data set. Let's go ahead and see if this works. Okay, so this is a standard color diagram that's just created as a scatter plot, effectively. So it's just using one of the standard elements for creating a scatter plot here. So this is your typical scatter plot. And the point that was made here is that if you use sort of like the default thing, then a lot of these points can be overlaid, and it's hard to actually tell where the highest density is in some cases. So an option to try to improve this is to create a two-dimensional histogram rather than a standard scatter plot. So we're going to go ahead and do this now. So here is a scatter plot, or sorry, now we're showing this data as a two-dimensional histogram. But what's nice here is that as you zoom in, it actually dynamically adjusts the binning. So what you can imagine doing is if you have a very large data set, it allows you to sort of seamlessly move between, like as you're zooming in, between the benefits of a scatter plot where you can see the individual points and the benefits of a two-dimensional histogram where you can see the densities. So this was with that subset of 20,000 objects, but this becomes much more useful when you have a large data set. So this is now with the full data set, which was, I believe, 20 million objects. And now when you zoom in, right, this will, as you zoom in, right, it's dynamically adjusting the binning. I think we can start to see the stellar locus here, and we can start to see the red sequence of galaxies. Let's zoom in more on that region. And it's dynamically rebinning as we go. So again, this is using the data shader capability to dynamically do the rebinning. If we were to zoom in more, so this looks like a numerical artifact of the way that the stars were modeled in DC2. We can zoom in and see that basically we have all these stars that were created in the simulation with exactly the same color. So this is sort of a non-physical artifact of the way that the DC2 simulations are created. So another feature that I want to show here is that it's possible to also get callback with the data shader. So if I wanted to zoom in, for example, and look at these anomalous objects, so let's suppose I wanted to analyze these, I could select them with a box, right? So now I've created a box selection. And then down at this cell, you can actually, we've defined the selection as we talked about previously, and we can show, we can basically get access to those indices, basically by having this bounding box that is a linked stream so that we can get that selection later. There's one more tool or sort of capability that I want to show, which is being able to make a selection and then not just have access to the indices in the notebook, but also being able to update a plot in real time. So this is an example of where it's a sky map, so right ascension and declination of the circular region of 4 degrees radius that contains the 20 million objects. And if we were to do a selection on the left plot, what's being shown in the right plot is a histogram that's being generated just from the objects that are in this box. So this is an example of sort of where we're like building up the capability to do these more, more involved interactive visualizations, but it's all based on this idea of basically defining a stream. So a stream, which is this box, that specifies the XY coordinates, linking that to the data, which is the points, and then defining a function that basically defines the custom callback that you want to have, and then linking that with a dynamic map, so that basically tells what's the custom callback function you want, and then has access to the streams, which is the selection box. And that is the end of this second notebook. Any questions on this part? If there's just a few minutes left, I'd like to show a third notebook. I won't walk through all of it, but like think of this purely as inspiration, of just to give a sense of what you can do. So this third notebook is it's in the contributed, the DP delegates contributed repository. So it's in a different repository. and it's called Interactive Image Catalog Visualization. It's building on the previous two notebooks, but this third one is focusing specifically on interaction, basically creating interactive visualizations that involve both the pixel level image data as well as the catalogs. So let me go ahead and show these just as examples. I won't talk through them in the interest of time, but I'll just show them as examples. This should render in just a moment. Okay, so what I've done here is that I've taken the same data set from the previous notebooks that we've talked about, but it adds some other interactive capability. In this case, what you can do is that you can change the color scale, right? So this is an example of where you can create a dashboard with, you could toggle to select different columns, or, in this case, it's adjusting the color range so that as you move these sliders, it's adjusting the plot in real time. This again, because it's created with this rasterize, when you zoom in, it dynamically repixelizes the image, which is nice. And also this has selection capability for the catalog objects that are overlaid. So if I wanted to say, hey, these look like anomalous objects on the periphery of this galaxy that probably got shredded, I could select those with the lasso tool and then have access to those indices in the next cell. So this is an example of the capability that we hope to use in commissioning, for instance, where when we see an anomaly, we can basically try to diagnose what's going on. I'll show just one more quick example. This is building on the cutout tool that was in an earlier notebook. I believe it was in this 03 image display and manipulation notebook. So what I'm doing is that I'm taking that cutout tool and I'm linking it with a scatter plot. So what I've done here is that I've basically given access to the scatter plot of tabular data that includes the flux and the flux air, but also includes other information that's available. And what I can do is I can select one of the points, and what it's going to do is that when you select one of the points, it's going to actually grab the postage stamp cutout from the data butler, so that it goes and it retrieves the image, it creates the cutout, and then on the fly, you can select objects that are in the scatter plot and then be able to see the image. So in this case, these are probably stars. They're probably bright PSF-like objects. If I were to click on an object up here, these are probably comparably bright galaxies, but now they're extended. So you have basically a lower signal to noise measurement on the flux. So you can see that some of these look extended relative to the PSF. There's a nice example. And if you go to basically lower fluxes, we should start seeing lower signal to noise objects. Let's keep on going to lower and lower fluxes. Now we're starting to see more of the noise in the background. Then if we go all the way down, these are objects that are sort of right on the threshold of detectability and may in fact be spurious. So anyhow, I should probably stop there to make sure that there's time for people to explore individually in as groups. But again, these were just meant to provide some inspiration for the more sort of involved dashboard like visualizations that you can create. So let me stop there.
Thank you, Keith. Give a big round of applause for Keith. That was a really nice presentation. A few minor technical hiccups, but I think that a lot of the concepts that Keith wanted to convey were successfully conveyed. Do we have any further questions for Keith? Jeff, are there any questions lined up?
Louise was asking how one can get access to this notebook. So I just placed, and I actually haven't tested it yet, but I think that if you use git clone, the git clone statement that I put in the chat, this should pull down all of the user contributed notebooks. I'll confirm in a few minutes. But otherwise, I'm not sure I saw any other questions, unless I missed some.
Okay, well, great. We can move on to questions and go into more depth on these notebooks in a breakout in just a few minutes. So we'll just spend the next 5 or 10 minutes or so having a look at some of the delegate profiles. I'll share the slide deck again. If I can, give me a second. Share screen. Okay, does everyone see the slide deck?
Yep.
You see Sherry? Okay, so is Sherry with us today?
Yes.
Yeah, go ahead, Sherry.
Everyone. Hi. So I'm a group leader at the Max Planck Institute for Astrophysics and a faculty member at the Technical University of Munich. My research interests range from gravitational lensing, particularly as a probe for cosmology, galaxy formation, evolution, supernovae, and I'm a member of the DESC and Strong Lensing Science Collaboration, and particularly also interested in the observing strategies for DESC and SLSC. And my DP0 specific interest is to look for mock strong lenses in DP0. So in the DC2, there are some mock lenses injected in there, and our research group here in Munich have been developing lens finding tools for this in particular. So Yiping Xu, who is also online here, and Raul Canamares, they are also both DP0 delegates, and the idea is to try to look for these mock lenses in DP0. And I'm certainly interested in collaborating on DP0 investigations. And that's it. Thank you.
Thank you, Sherry. Okay, Brant.
Hey everyone, I'm Brant Robertson, professor at UC Santa Cruz. I'm a former chair of the Galaxy Science Collaboration. I've been a member for 13 or 14 years now, which is amazing to think about. So I'm interested in galaxy evolution in general, but specifically with Rubin in this case. So one thing we've been doing with a student here, Ryan Housen, who's a computer science PhD student, is we've been developing pixel level classification tools based on deep learning models, where pixel by pixel, you can come up with some kind of categorization of the images that you have. So in the lower left, you can see an image from the Hubble Ultra Deep Field, and on the right, you see a pixel level classification of whether the pixel belongs to a disk or a spheroid or a point source or a regular galaxy. And so we're trying to integrate this with the data, the Rubin Science platform through DP0. So that's what I'm working on. Of course, I'm interested in talking with people. I'm definitely interested in how we interface community software that already exists with the RSP. That's one of my main interests in DP0. So thank you.
Thank you, Brant. Kristen.
Hi, my name is Kristen Larson, and I'm at Western Washington University here in Bellingham, Washington. My interest is interstellar dust, and recently about how to make corrections for interstellar dust more accessible to the wider community. So in particular, I'm one of the main authors of the AstroPy tutorial on using some of the code that exists on as an AstroPy affiliated package. I'm working on a notebook that I will be presenting here at one of the delegate assemblies the first week in November to show how that works. So how we can install some of the code that exists on GitHub and use it within the Rubin Science platform. I'm a member of the STARS and Milky Way Science collaboration, and I have been a member of that collaboration for 1 day. So I'm super excited. And I'm very interested in working with folks who are interested in interstellar dust. There's not a lot of extinction in this high latitude DC2 field, but I'll show you how to find it in a few weeks. Thanks.
Thank you, Kristen. Alexandra.
Hi, everyone. Nice to meet you all. I'm Alexandra. I'm currently a postdoc at Fermilab in Chicago. And I'm also part of DESC, Galaxy collaboration, and Informatics and Statistics collaboration. So my biggest interest is related to galaxies, evolution, formation of galaxies, and especially galaxy mergers. And on the other side, I really care about using deep learning to study galaxies. And I'm particularly interested in developing, and those are the things that I work on, developing domain adaptation methods that are going to allow us to work with simulated and real galaxies at the same time. And to be able to really perform some regression or classification tasks on new real data. So that is one of the things that I'm interested in doing within, DP0 and future Rubin data, so that we can learn from, for example, current simulations that we have and actually apply right away our models to the real data once they become available. I'm interested in collaborating on any kind of project related to galaxies or working with images or deep learning. So yeah, feel free to contact me if you have any kinds of ideas related to those topics. Thank you.
Thank you, Alexandra. Okay, Deca, is that what I should call you?
Yeah, hi everyone. I'm Decker French. I'm at the University of Illinois at Urbana-Champaign. My science interests are in transients from supermassive black holes, especially tidal disruption events. And so I'm broadly interested in transient host galaxy connections and galaxy evolution. Within DP0, I'm definitely interested in collaborating, chatting science in transients, galaxies, AGN, all that. I'm especially interested in identifying supernovae and, in the future, other transients in the centers of galaxies, and trying to characterize the noise that will come up when we try to do that. So thanks, and nice to meet you all.
Thank you. Okay, Natasha.
Hi, I'm Natasha. I'm a first-year grad student at UC Berkeley, working with Jessica Liu. I'm interested in all things microlensing, specifically Bechtol microlensing, and I've been adding binaries to our group's microlensing simulation code, where we simulate a population of objects, including compact objects, and do a mock microlensing simulation. I'm interested in photometry. I'm getting involved with looking for microlensing in CGF and hoping to apply those methods to Rubin. I've also been helping out with the cadence discussions with specifically for microlensing. Of course, I'm interested in collaborating and specifically with DP0. I'm interested in learning to manipulate the light curves and identify microlensing events and transients in those. Thanks.
Great, Natasha. All right, and Vincenzo.
Hi everyone, I'm Vincenzo. I'm a first-year PhD student at the University of Naples, and my mainly interested. I am principally interested in AGN's optical variability, transients, and supernovae, and difference image analysis. As a specific interest for DP0, I am interested in the analysis of light curves to study and identify variable sources, especially supernovae. And I am currently working on a notebook to study supernovae light curves as part of a project I presented with Fabio Augusto and Maria Teresa Botticella. And the things I want to learn waiting for DP0.2 is the use of difference images to study variable sources in host-dominated galaxies.
Great, thank you very much. I think Vincenzo's the last. Yes, nobody else added any slides. So thank you very much to all those 7 delegates who added their profiles and slides. It's great to hear from you. It's really exciting to hear what people are interested in and starting to do with DP0, and really, great to get to know everyone. So I'll stop screen share now. We're going to move into the breakout rooms now. And I think, Jeff, have you been setting up the breakout rooms? Where are we on that?
about to, but I wanted to make sure we gather suggestions for any breakouts. I just realized I don't have edit permission on the slide deck, so I haven't updated the suggested breakouts. But yeah, we had one for to continue the resolved stellar populations. So that will be one. We also had, let's see, what else did we have here? We had the, we can continue the advanced data visualization discussion following on the presentation for today. There was a request for a supernova working group. And were there any others people would like?
So I think if you stay in the main room, it's just a general Q&A about the science platform. So that's not about the tutorials and the notebooks, more just Q&A about the science platform. Did you mention the visualization, Jeff? I think you did.
Yep.
Yeah. Yeah, I think that's it, unless anyone would like to suggest another breakout room, would like one set up. No, okay. All right, so let's set those up, Jeff. Actually, Jeff, while you're setting those breakout rooms up, we could have a delegate presentation from Tom. I didn't refresh the slide deck before I presented it. So Tom, would you like to introduce yourself now while Jeff's setting up?
Or if you show the slide.
Oh, let me just do a screen share again. Okay, can everyone see Tom?
Yep.
Excellent.
There we go. Thanks, Leanne. My name's Tom Lorado. I'm at Cornell University. My main position is in the research faculty in astronomy, but I also have a teaching and student advising position in the statistics department. My main science area is more a skill set than a science area. It's astrostatistics, especially Bayesian methods for time series and demographics. I was one of the people introducing those methods into astronomy back in the 1980s and 90s. Having that kind of skill set as my focus has let me work in a lot of different areas that I've listed here, including several related to Rubin. With Rubin and DP0, I'm the founder and one of the co-chairs of the Informatics and Statistics Science Collaboration, the ISSC. I'm also a member of DESK's PhotoZ working group. And my DP0 interest is I'm trying to get more participation of the non-astronomer members of the ISSC with Rubin. So I'm having an eye on trying to build tutorials for and with other ISSC members to try to get them more involved. That's it. Thanks, Leanne.
Thank you, Tom. Your experience in astrostatistics will be very applicable across many of the science areas of interest in the data previews and for LSST. All right, I'll stop share. Okay, how are your breakout rooms? So
okay, I created some rooms. Hopefully I did this right.
Looks good. So I see data viz, I see stellar populations, results of populations, supernovae, and miscellaneous.
Yeah, and I just created a miscellaneous just in case anyone else wants one, wants another breakout that is available, and we can rename it and have other discussions there.
Okay, great. Well, thank you, Jeff. So if people would like to go to the breakout room of their choice, yeah, we can continue working